you need a background?
So let's take a look here. So it talks about, of course, that these repeat, that they are periodic. And you can see the curve here. If I could continue it, hill, valley, it could keep continuing on and on. That's all that this is saying because they're periodic. That's as wild as that is. Now, different things we're going to have to know to draw these graphs, okay? First off, the period. How often does the graph repeat? How many pi does it repeat? So to find the period, for sine and cosine, you're going to do 2 pi, that's your full circle, divided by b. And I'm going to write this in a sec. I'm just pointing out to you where b is. B is always the coefficient on x. Same for secant, cosecant, tan, and cotan. B is always the coefficient on x. And the period for sine and cos, same for secant, cosecant. Everything I'm telling you for sine and cos is going to be carried over for secant and cosecant. Amplitude. How tall are the curves? That's the amplitude. That's the height. So I'm just going to put in parentheses so you know what that means. That is the absolute value of A. And notice A is the lead coefficient. So absolute value, that's how tall they are. So if you have a 5 in front, 5 up, 5 down, they're going to be very tall. Increments. So the increments are how you scale your x-axis. If you look at my little graphs over here, you can see like there's these 4 green tick marks. Those are the increments. It takes 4 increments to make one full period. To find the increments, it's the period, whatever you got for the first step, over 4. Because it takes 4 tick marks to make one complete period. Okay, reflections. Now, our standard, so let me take anybody's bag here. Our standard sine graph is what I call a hill and a valley. Hill and a valley. Now, it reflects or it flips to valley hill if we have a reflection or a negative on the lead coefficient. So I'm going to put if A is negative, I'm going to get fancy here, I'm going to say it reflects over the x-axis. So how that would affect cosine, if you had a reflection and negative lead coefficient, cosine, our parent function of cosine is one big valley. It, of course, would flip and be one big hill. Would it be how you would do the reflection on it? So pretty easy on the reflections. Now, phase shifts. Sounds fancy, really, isn't it? Phase shifts is the terminology they use for your left and right, your horizontal shifts, which we're used to seeing those. So I'm just going to put in parentheses, it's your horizontal shift, what that really means. Now, to find the horizontal shift, so it might move to the right or to the left, you're going to take that entire expression with x. So if you look in both of them, it's that bx minus c. And we're just going to set it equal to 0. And of course, you would solve for x. So you're going to add c, divide by d, do whatever you're going to do to solve for x. I'm just going to put solve for x. So lots of crazy information. And we're going to start, like I said, easy, and work our way up to some more complicated transformations. If I get through everything today, great. If I got to finish a couple tomorrow and you get some time to work on the homework tomorrow, fine. We're just going to kind of see how the day takes us. The key, first thing I'm going to find, period, amplitude, increments. Those are the key to get everything drawn and marked out. Now, every graph, you're going to have to draw 2 full periods. What I have up here on the board, that's 1 period of sine, 1 of cos. So you can repeat the second period. You could just keep adding. You could go to the left and subtract it. But each graph, you're going to have to do 2 full periods. So not hard to draw, just, kind of time consuming, as always, in math. So we're going to do our basic parent function, kind of the rough sketch I have over there. We're going to draw it a little more bougie here and put all the details in it. Now, amplitude, absolute value of A. Well, we don't have a lot of numbers here. Technically a 1, absolute value 1, 1. So I'm going to 1 up, 1 down. Period. 2 pi over b. And of course, b is the coefficient on x, which is a 1. Well, 2 pi over 1, 2 pi. Okay. Increments. I'm just going to jot it on the side here because I don't think my blank's long enough to fit it. The period, which we get 2 pi over 4. because it takes, of course, 4 increments to make a period. Now I'm going to reduce that. I'm going to make that pi over 2. So that is how you're going to count or scale your x-axis. We're going to add by pi over 2 every time. And I'll get to the starting point when I get my graph going. All right, let's draw our x and y axes. I'm going to kind of draw them in the center here. You know my drawing skills. I'm going to try to put it in the center. No promises. And then, of course, from there, I'm going to count out my amplitude. Up 1, down 1. So that's going to be the highest point, lowest point. Next thing I'm going to do is get my increments on. So pi over 2 is how we're scaling. It takes 4 increments to make 1 full period. So I'm going to do the first period here. So 1, 2, 3, 4. And we're counting or scaling by pi over 2. So you do have to be kind of good with fractions. Because think of that as a half. Half plus another half pi. 1. 1 plus another half. 1 1/2, or I'm going to write it in proper, it just fits in there a little nicer. 1 1/2 plus another half. And that's our full period. Our period was 2 pi, there we go. So let's get the first one drawn. So our standard sine curve, no reflections or anything, is the hill and the valley. So I'm going to start here at the origin. I'm going to fill that in. I'm going to put a little note over here that sine starts at the center line. Because the information is pretty similar, obviously, for cosine, the starting point's going to change. Now, of course, notice I got fancy and said center line. Ours right now is 0, 0, because I don't have a vertical shift. When I have a vertical shift, it's going to change or affect my starting point, but I don't have to worry about it right now. Elliot, was that your question?
Well, I was going to ask why you didn't say the origin, but I see.
I'm leading to it. Okay, so our standard sine should be our hill. So now I'm up at the maximum height, back to the center line, down to my lowest point, back to the center line. And then I'm just going to try to curve that on. And there's 1 complete period of the sine curve. Now, and this really is a spacing thing. So it really is. It depends on if I have a phase shift. I might do both periods to the right. It depends how much room I have. If I don't have a phase shift, I just make my life easy and I do the first period on the right and the second on the left. I just subtract half a pi. So it's all the negatives, it's all the reflections of that, and it's easy for me to mark it out. So I'm going to have negative pi over 2. Subtract another half. Subtract another half. Subtract another half. And then I'm just going to repeat. I'm going to draw it in red just to designate as the second period. I need that hill and the valley. So that is 2 full periods of our sine curve. And again, we're sketching these, not super accurate. I am going to talk about if you can do them on your graphing calculators. And I'm probably going to complain about no, I will complain about Texas Instruments. You can, they're not super detailed, but you can. We'll talk about it. All right, let's take a look at cosine then. So let's just do a little prettier cosine graph than what I have up on the board. All the information you calculated the same. The amplitude's absolute value A, period 2 pi over B. Everything is going to be the same. Obviously, how we draw it's going to be different. So amplitude, absolute value A, period 2 pi over B. B is 1 again, 2 pi over 1. Increments, period over 4. 2 pi over 4 is that pi over 2 again. And we'll talk about the starting point when we get the graph going. So really, I'm drawing the same x and y axes. I'm marking out that first period increments the same. The graph itself will be different. Okay, so let's do our amplitude, up 1, down 1. And then 4 increments, 2, 3, 4 to make a full period. And we're scaling by that half pi again. Give me a second to get all that marked. You can mark your second if you want to get into it. So all the information for sine and cosine is the same. How you mark it out, everything's the same. Clearly drawing it's going to be different. The key difference is your starting point. Cosine starts at A. So our A, our lead coefficient was 1. We are starting up there at 1. Because cosine should be the one big valley. So I'm at my max height, back to the center line, down to the lowest point, -1, center line, up 1. So there's my one big valley. Now I need the second period. I'm going to list my starting point. We started up there at 1. I'm just going to go to the left side and do all the reflections, the negatives of our increments. And I'm going to repeat that same curve. And I'm just going to draw this one in red just to differentiate it's the second period. So any questions on the first two? Because we're just going to get fancy and throw some other numbers in. Now, let's talk about your calculators. If you want to look at it. 1, your mode needs to be in radians, okay, because clearly all the 2 pi were in radians, not degrees. So I would just type it in like normal. So I'm just going to punch this one in cos of x. I don't know if I love it, okay? Because it kind of gives you the idea of the curve, but I don't think it's super detailed. It's not going to label these increments on the x-axis for you. It won't give you 2 pi, 3 pi over 2, etc. So clearly you're going to have to do that. But I guess if you're ever like, oh gosh, what does it look like the curve? I don't know. You can do that. You can look at the graph on your calculator to kind of help the cause. To kind of help the cause a little bit more too, like if you were like, oh gosh, is this really the same graph? You could match up this first period. Meaning, I'm going to change the window. I'm going to start at 0 and go out to 2 pi. So I'm going to hit window. I'm going to change my x-min to 0. And I'm actually going to type in 2 pi here. 2 pi. And you can change your y also if you really want to try to match it up if you're unsure. Like you could change your y, because they're on 10, -1 and 1. So that maybe matches ours up a little bit. But personally, I find that kind of obnoxious and a lot of work to get it to match up. I usually trust the graphic skills. Boom. Elliot.
Can't you just find the local maximum and local minimum?
Yep.
Or just one?
That will give you the height of it for sure.
Mm-hmm.
But the only thing I hate it, well, and even like Desmos doesn't do it, they won't give you these increments. It won't spit out the 2 pi, the 3 pi over 2. It won't give you that. It would give you the decimal form of it, but I'm going to want it with the pi in it, the exact. But at least you can kind of get an idea. Now, obviously, I've changed my window a lot, so I'm just going to hit zoom 6, put it back on the standard, just for future reference. Just to kind of show you, you can use it a little bit as a guide. All right, so now we're just going to get fancy and throw some other numbers in here and take a look at how it affects our graphs. So all the calculations are the same. Amplitude, absolute value of A is 2. So let's talk about my drawing skills. So this should be twice the height of the last graph. Is it actually going to be twice the height of my last graph? Maybe, I don't know, I'm going to try, but technically it should be, okay? Technically, right? Period, 2 pi over b. B, of course, is 2. Okay, now, our parent cosine period is 2 pi. We're going to 1 pi. So, in theory, my new graph should be twice the height as the last one, half as wide. I'm going to try to show it. I can't guarantee it's going to be perfect. We're going to try. Increments, period over 4. And we'll get to the starting point. So am I going to be super big? You're like, oh, this isn't twice the height and half the width. No. But I'm gonna try. We're gonna try. Okay. So now our amplitude going up to 2, down to -2. Is that literally twice as tall as the last graph? If we measure, I don't know, probably not, but okay, we're gonna try. Now, it should be, oh Lord, it should be half the width. Now, if I try to cram in 4 increments in half that space, it's gonna get real congested and very messy. So I'm going to try my best to make it a little tighter. I don't guarantee that that's half the width as the last one, but I'm going to try. And we're scaling by quarter pi. So quarter plus a quarter is a half. Half plus a quarter, 3/4. 3/4 plus one more quarter, of course, is 1 pi. Okay. So let's get our first period drawn. Now, we have a cosine curve. Remember, cosine starts at A. Our A is 2, so I'm starting right here at 0, 2. Back to the center line, down 2, center line, up 2. So there's our first period, and I'm going to do the second on the left. I could keep going to the right, but it's just nice and easy to do the negatives on the left. So negative pi over 4, negative pi over 2, negative 3 pi over 4. Same curve. So is it twice as tall and half the width of the last one? I don't know, probably not. But I tried, okay? And that's all I ask is try. Try. Any questions on C? All right, cruising on. Okay, D, catch the negative. The negative's important. And of course, we've got the 2. So, amplitude, absolute value of A, absolute value -2, 2. Your amplitude's always positive because it's the absolute value. I just want the height. Period 2 pi over B. B is our 1, 2 pi over 1. Increments, period over 4, 2 pi over 4. And we'll get to the starting when we get there. All right, so amplitude of 2, down to -2. Now this time, of course, our parent graph, the period's 2 pi, which is this one also, so I'm not worried about shrinking it. I'm just going to start scaling by my half pi. Half plus a half, 1 pi, 1 plus a half, 1 1/2, plus another half. Okay. And we've got a sine curve. Remember, sine starts at our center line. Well, for us right now it's 0, 0 because we haven't had any shifts. Careful. It's not going to be hill and a valley. It needs to be valley and a hill. We got to reflect it because you have that negative lead coefficient. So I'm going to go down -2. So there's my valley. There's the hill. And of course, I'm just going to repeat the thing on the other side. And I'm going to list my starting point. We started at the origin 0, 0. 1, 2, 3, 4. Okay. I'm just going to draw the second period in red just to designate. So my valley and my hill. All right. I feel like it's like adult math coloring. Elliot, what do you got for me?
Isn't sine and cosine pretty much the same, but just shifted over by 1 increment?
For sure. For sure.
Well, not 1 increment, by 1.
It's like they're parts of each other. Yes, 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 for sure. So the next example, you can see I'm keeping an eye on the time. Again, wasn't preparing to do everything today because it is kind of long. The next few, of course, we've got some more fractions and some more shifting in them. So let's just kind of see what we can get through. So through a fraction at you, big deal, okay, we can handle it. Amplitude, absolute value A, 1. Now, period. Careful here. I know you can handle your fractions. Period, of course, 2 pi over B. I'm going to jot it on the side because I got to do a little work here. B. What fraction is the coefficient on X? 1/3. Okay. So we have to figure out 2 divided by 1/3. What's 2 divided by 1/3? It's going to be 2 times 3, so 6 pi. So you can see I'm kind of cringing because I'm like, oh God. Because our parent function's 2 pi, I should have it 3 times the width. I don't know, it might happen. We're going to see. Increments, of course, period over 4. So I'm going to reduce that down. I'm going to make it 3/2 pi. Now, again, I'm not going to be like, oh my gosh, that's not 3 times the width of the parent. No. I'm just going to use my space. I'm going to try to make it as wide as I can. I'm not worried about the height, the amplitude 1, that's whatever. But it is stretched out horizontally. So I'm using all of my space. Do the best you can. Okay. So this time, of course, I'm just using my space. I'm going to space my increments out as wide as I can. Is this 3 times the width of my original parent graph? I don't know. Probably not, but I'm going to try. Scaling by 3/2 pi. Or if it helps, 1.5. 1.5 plus 1.5, 3. 3 plus 1.5, 4.5. And I don't care if you put 4.5. I have kids that like to write the mixed number. I don't care, it's fine. I just make improper because I take up less room. 4.5 plus 1.5, 6. Okay. Now, sine curve. Sine starts at the center line. Ours is still at 0, 0 because we haven't had any shifts on this yet. Yeah, keyword yeah. Positive lead coefficient, positive, so I want the hill, then the valley. There's the hill, valley. Yeah. A little rough drawing there. Okay, and I'm just going to do, of course, my second period on the left. Just trying to use all my space. I'm just going to repeat the hill and the valley. Oh, that kind of got away from me. That's not my best drawing right there. Yeah, okay. Yeah, okay. No judgment, kids. Any questions on that guy? All right, last one with some fraction work before we get into some crazy shifting. We'll give one of the shifts today. We'll finish them up tomorrow. So amplitude, of course, absolute value at A. Now, period 2 pi, this is going to be good, over B. Our coefficient on x is 1/4. What's 2 divided by 1/4? 8. So it should be 4 times the width of the parent function. I don't think that's not going to happen. It's just not. Increments, period over 4. Well, I like that. 8 pi divided by 4. That comes out pretty nice. I like that one. Okay. So we got. So again, I'm just going to try to use all my width. I'm going to do the best I can. Amplitude 1. And I'm going to try to space out the increments as much as I can. Whatever space allows for. Is it much different than the last one? I don't know, probably not, but I'm trying. Okay, 2 pi we're scaling by. I like it. 2 pi, 4 pi, 6 pi, 8 pi. Now, careful. It's cosine, but your lead coefficient is a negative. So we got to reflect it. It's not one big valley. We got to flip it. One big hill. Or remember, cosine, I think always to myself, it starts at A. Well, A itself is -1. So I'm starting there. I kind of scribbled over the negative. Sorry. A starts at -1. Back to the center line. So there's my one big stretched out hill. I'm just going to go to the other side, all the negatives. I'm going to try to use my space. Okay. Let's see what we got here. Same thing. Start. Oh, that kind of got away from me. Close enough. Any questions on that? All right, let's do one of the shifts, the up, down, left, right, and then I will give you your homework, but it's not due tomorrow because clearly I got to finish your notes tomorrow. But if you want to start it, you can, etc. I just don't want to race through it. So here we go. Still more of the same, more of the graphs, but notice you are adding or subtracting something to x. That's our horizontal shift, or what we call with the trig functions a phase shift. So it's going to move it left or right. This one you can see I've got a phase shift and the -3 at the back. It's going to change it down 3. So now we're start moving them around, which makes it a little more entertaining. So here we go. Amplitude. Same thing, absolute value A. Period. 2 pi over B. And of course, b is just the coefficient on x, so 1. Nothing exciting here. Increments, period over 4, 2 pi over 4, nothing wild. Here we go, phase shift. Now remember, to do the phase shift, you take that, you can probably mentally do it, I'm just going to jot it down on the first one here. Take that expression with x, we set it to 0. Most of you can solve that in your head. You're going to add pi over 4. So that means sine. What am I going to say? So picture my sine graph shoved down the right side, pi over 4. So it's going to be off of the origin for a starting point. It's going to be down at pi over 4 to start at, which we're going to draw here in a second. Now notice I got fancy here, and I have a blank for center line, okay? Because we're going to start moving the center line. The vertical shifts, the up and down. Easy question. Don't stress it. What are all these center line equations been so far? Y equals, have you gone up or down at all on these? What's the x-axis? Y equals 0. So I'm just going to put y equals 0 because we haven't shifted up or down. All right, so start at the same, draw your axes, mark your amplitude. Don't start anything on the x-axis though. Amplitude of 1. Okay, now difference is, first thing you have to put on your x-axis is your phase shift. So the first thing I'm going to put a tick mark for is pi over 4. So instead of 0, 0, this is where I'm going to be starting. So I'm going to go ahead and fill in the starting point is now pi over 4, comma 0. And it takes, remember, 4 increments to make a period. So I need 4 more past that. And that will be my first full period. Now here's where our fraction skills come into play. Get ready. You're starting at a quarter and you're adding a half. Pi, I'll put the pi in obviously. What's a quarter plus a half? 3/4. What is 3/4 plus a half? 5/4. Now let's get real. Here's where I kind of stop getting in a twist about it. What's the pattern? The numerators are going up by what? 2, so make your life easy. Now, before I draw anything, notice I ended at 9 pi over 4. I didn't screw up. What's our period again? 2 pi. Not ending at 2 pi because you started at a quarter. What is the difference from 1/4 to 2 1/4? 2. We are covering 2 full pi, but you're starting at a quarter and we're ending at 2 1/4. So that's why you're not ending right at the period. Elliot.
Can't we just mark the increments as pi over 2 and then split the first increment in half?
Long as I have pi over 4 somewhere on there. All right, what do we got? Sine. So of course, starting at the center line, which ours is now shoved over here at pi over 4. There's no reflection, so I need the hill and the valley. So there's the hill, valley. Got it? There's the first full period. Now, the question is, here's where it gets kind of dicey sometimes. Where do you want to draw your second period? We could go to the left. I could subtract a half pi. I don't care. If you have room, you could add 4 more out to the right and just keep adding 2 to the numerator if you're in that pattern and the habit. I don't really care. I'm going to go to the left. I think I got room to go on the left a little bit better. That's how I'm going to roll. So we're at a quarter. Now I'm subtracting. Oh boy, subtracting a half. What's a quarter minus a half? Quarter, negative quarter, good. Minus a half. What's negative 1/4 minus 1/2? Negative 3/4. We see the pattern, right? We're going down by 2, so I'm not going to stress here anymore. Now, you need 4 past the starting point. 1, 2, 3, uno más. And just like all the others, I'm going to draw my second period in red, just for dramatic emphasis. There is my hill and the valley. Any questions on that? Okay, so like I said, I'm going to give you your homework assignment. It is not due tomorrow because clearly we need to finish going through all the shifting. I will finish that up. FYI tomorrow, and also bring your Chromebooks with you tomorrow too.